In this video, we are going to study carbon and its compound. It is the fourth chapter, class 10th NCERT. We will study carbon and its allotropes and also the carbon forming compounds, uh, spec- especially hydrocarbons. Okay, let's start. The Earth crust has only 0.2% of the carbon in the form of minerals like carbonate, hydrogen carbonate, and coal and petroleum. And the atmosphere has only 0.03% of the carbon dioxide. So, carbon is not present in a natural form in its pure form. It is present either in a carbon dioxide, which is in atmosphere, and some minerals like carbonate and these, and very few amount on the surface of the earth on and even on the in atmosphere and on the surface. uh, like let's talk about the bonding in carbon, covalent bond. So there is a carbon bonding in carbon. So we will study here why carbon is like basis of many compounds, and why carbon, how does the carbon have that much tendency. So we saw that the ionic compound have high melting and boiling points and conduct electricity in solution or in a molten state. This is what the properties of ionic compounds. We also saw how the nature of bonding in the ionic compound explains these properties. And let us study now the properties of the carbon compounds. Most carbon compounds are poor conductor of the electricity. They are poor conductor of the electricity, as we have seen in chapter 2 from the data table from 4.1. This is a 4.1. The boiling and melting point of the carbon compounds are very low. Look at this. In last few chapters we learned like ionic compounds have a very high melting point. It is more than the 1000. It was more than the 1000 degrees Celsius. It ranging from 1000 to 2000 degrees Celsius, because it we needs lot of energy to break the ionic the ionic bond, which is due to the electrostatic which is a kind of electrostatic bond. So these compounds have a low melting and boiling points as compared to the ionic compounds. We can conclude that the forces of attraction between the molecules is not very strong as compared to the ionic bonds. Since these compounds are not largely not conductor of the electricity, we conclude that the bonding in these compounds do not give rise to any ions. We know that the reactivity of the element explained in reactivity series we learned in the like metal and non-metals chapter. And the more reactive is the element and higher in the reactive series, the more it has a power to displace the lower less reactive element, and more it has tendency to attach with some other electron, some other atom to make to make a molecules. So we know that the reactivity of element is explained as the tendency to attain the complete filled out outer cell to complete its outlet, that is to attain the noble configuration. Element forming the ionic compound achieve this by either gaining or losing the electron in the outermost cell. So gaining or losing electrons, this is what happens in ionic compounds. So if we here gain or lose the electron, what will happen in case of a carbon? If carbon has a valency of 4, and the outermost cell has a 4 electron, either it needs 4 electron to make outlet to make the outer cell complete, or either it can lose electron. What happens in both cases? Let's discuss this. It could gain 4 electron forming carbon 4 minus ion, 4 negative ion, but it would be difficult for a nucleus with a 6 proton to hold the 10 electron. It already has 6 proton in its nucleus and 6 electron around it, and if it and around it, and 4 are in the 4 are in the outermost. If it is gain 4 more, to complete the outer shell, like let me explain this in this way. It has 6 proton and 2 electrons are in there, and 4 electrons are in outermost shell. So to make the outer this is K, this is L. To make this L cell aucklet, to reach the aucklet, it needs 4 electron. So addition of a 4 electron, what will happen? Addition of the 4 electron, uh, it will be difficult. It will be difficult for the nucleus with 6 proton to hold 10 electron. So atom will become unstable because 6 proton cannot hold the 6 electron, as the equal number of proton is the number of proton and number of electron should be similar, so that can the both the negative and positive charge can remain and atom remain stable also. So in case it cannot remain stable, in second case losing the 4 electron to make the, and these 4 electron can be removed, and but we will require large amount of energy to remove 4 electrons, leaving behind a carbon cation with a 6 proton in its nucleus and holding just 2 electrons. So it will, removing the 4 electron will require large amount of energy. So how does this carbon overcome from these two problems? Carbon overcome this problem by sharing the valence electron with other atoms. So what is sharing? It needs, these are the valence electron. So it will share all the valence electron and will make it its outlet complete. The shear electron belongs to the outermost shell of the both atoms, and so both atom is important. Both atoms shares. If it is sharing with some, suppose X atom, X has a 1 electron, so they both will share one electron. This is how it gains 1 electron from this, it is to gain 1 electron from this. So if X has a 1 electron, so it needs 4x, 4x, because to make the outlet complete. One for here. So it got the 4 electron total in the outlet. So this is by sharing of electron, shared electron, and lead to the both atom attaining the noble configuration. It also got a noble configuration based on its valency. Suppose it has a valency of only 2. Suppose this is a hydrogen atom. This is what hydrogen atom do. Attaining both got a noble configuration. So carbon, how carbon is like attaching with other molecule? By sharing the bonds, sharing the electrons between the both. So this is an example of one, when hydrogen has a 1 valency, 2 hydrogen get attached and both shared their electron. So both get the K cell got the 2 electron, which is like complete cell. And this is why in nature we don't find H alone, we find H2, because H2 is a like a stable position for the electron, for the atom hydrogen. Okay, in order to attain the aucklet, each nitrogen atom in a molecule of nitrogen contributes a 3 electron, giving rise to the 3 shared pair of electron. So what is happening in case of oxygen? Oxygen is also forms, oxygen is not found in O, it is found in O2. Why? Because when the two oxygen molecule attaches, it forms a covalent bond, and the configuration of their outermost cells become like noble configuration, like they reach at the 8 electron in the outermost cell by sharing them. So nitrogen do this by sharing 3 electrons of each element, each atom shares 3 electron, and here is each atom shares 2 electron. So it is forming double bond. If single atom is shared, it is formed single bond. 2 atoms are shared double bond, and 3 atoms are shared by both triple bond is formed. So in nature, these are found in a N2O2 triple bond between hydrogen atom. Uh, and carbon is a tetravalent because it has a 4 valence electron. Bond formed by the sharing of electron pair between the two atoms are known as covalent bond. These are called covalent bond. Covalently bonded molecules are seen to have a strong bond within the molecule, but intermolecular force is weak. They have a strong bonding, but the intermolecular force between the two molecules, suppose there is another n2 molecules, and between the intermolecular force this will be weak. And however, the both these bonds have triple bonds have a strong, this gives rise to the low melting point and boiling point. So what rises because the weak intermolecular force, these will break when while heating. These intermolecular force will break and they will apart, and the constituent particles that we study in 9th class will get detached, and they can move randomly around, and this is why they reach from molten state or boiling state. This gives rise to the low melting and boiling points of these compounds. Since electrons are shared between the atoms, no exchange of a particle is found. Such covalent bonds are generally poor conductor of the electricity. Why they are poor conductor? The electron are shared between the atoms. No charged particles is formed. If no charged particle is formed, then the such like bonds cannot form. Such compounds cannot conduct electricity. Let's discuss about the allotropes of the carbon. Like we have discussed about how carbon is forming the covalent bond. Let's discuss about the types of, if how what are the types of bonds by which the carbon forms different types of substance. Like we have a three allotropes of carbon. The element of carbon occur in three different form in nature. One is diamond and another is graphite. So actually these are the only two natural found. One more thing is another which is artificial. So diamond, each carbon has a four bonded with the four other carbon atom. In diamond every carbon atom has bonded with four other carbon atom, but in diamond it is only bonded with the three carbon atom. So although so it bonded with the three, but in one bond there is a double bond. And the graphite structure is formed by the hexagonal ray between being placed in layers above and another. And also in the graphite conduct electricity, and the diamond do not conduct electricity. And graphite is a smooth and slippery, and graphite is also good conductor of electricity. Diamond can be synthesized by subjecting a pure carbon at a high temperature and pressure. Another allotrope is a Buckminster fullerene. So fullerene is another class of allotrope. The first one to identify was the C60, because it contains 60 carbon atoms, which has a carbon atom arranged in a shape of football. And since this look like a geodetic dome designed by the US architect Buckminster Fuller, the molecule is named as fullerenes. So these types of pentagonal structures or hexagonal structures formed by the carbon which looks like a football are called fullerenes. So this is an example of a C60. Why C60? Because it has 60 carbon atoms. So we just discussed the versatile nature carbon forms the valence bond. Let's talk about the versatile nature of the carbon. The number of carbon compound whose formula are known to chemists was recently estimated as a millions. And carbon has a unique ability to form bond with other atom of carbon, giving rise to large molecule. and this property is called catenation. This is a very important from exam perspective view. What is the catenation? The ability to form a bond with other atom, that giving rise to large number of molecules. If carbon is forming bonds with lot of other molecules like N, so this property is called catenation, and carbon has this catenation property. Compound of a carbon which is linked by only single compound, which is linked by single bond between the carbon atom is called saturated carbon atom, and carbon compound having a double or triple bond are called unsaturated. So saturated where single bond are there. In case of double bond and triple bond, the carbon is called unsaturated, and single bond carbon is called saturated carbon. No other element exhibit the property of catenation to the extent carbon compound. So carbon has the highest catenation capacity, and the carbon-carbon bond is the strongest and hence stable. One reason of the formation of the strong bond by the carbon is a small size. This enables the nucleus to hold and share the hold to the shared pair of the electron strongly. So the shared pair of electron can be held by the nucleus so strongly, so it forms the strong bond between them. So the bond formed by the element having a bigger atom are weaker, much weaker. So because nucleus cannot has much ability to hold these electrons. Organic compound, two characteristic features seen in the carbon, that is tetravalency and catenation. Tetravalency is it forms four bonds. It needs four. It has a four valency, so it can it shares with the four electron. It needs four electron to complete its outermost shell. Catenation is a property of carbon by which it can form bond with other atoms and carbons, other atoms, so that it can form a long molecule, large molecule. That gives rise to a large number of a compound. So he was a scientist in 1828 prepared the urea from the ammonium cyanide. We have already discussed that saturated are single bonded, unsaturated are double bonded. So here carbon, two carbon atom, carbon needs 8 electron. So two got shared with this carbon and two each by hydrogen. So it forms this way. If it is sharing with the one electron, then single bond will come. So this is what the molecular formula of this molecular structure, and molecular formula will be C. It has 3. This will be the molecular structure, molecular formula, and the valency of all the atom are satisfied by the single bond between them. Such carbon is valency satisfied by the single bond between them. Such carbon compounds are called saturated. These compounds are not very reactive. They are not very reactive. And what are the double bond? If it is sharing two electrons, here in this case 2 electron by each atom is shared, and to make their four, they gain the 4 atom. So such compounds of the carbon having a double or triple bond between the carbon atom are known unsaturated. Unsaturated has a double bond, a triple bond, and they are very reactive, more reactive compared to the saturated carbons. And carbon forms bonds in 3 types. One is chain, one is branches, and another is rings. Methane, ethane, these are the formulas. Like CS4 is called methane, then 2 carbon it is called ethane, propane, butane, pentane, hexane. One is for meth, 2 is power 8 prop but pent hex hex, then hept oct non dec. So these are the names, prefix. These are called prefix, and these are called suffix. So in which this is carbon is a like branching. It is a, this form is a branching of the carbon. Chain, branches and rings. Here the chain type formation, chain appearing formation is formed by the carbon, and here is branch appearing formation. Branches are, these are branches, and here is a ring formation is there. This is how by three category: by chain, by branches, or by ring formation. Carbon molecule forms a compound. Also, if the single bond is there, the suffix will be ane, and in case of double bond it will be ene. In case of triple bond it will be yne while naming these molecules. Carbon will contain only one only carbon and hydrogen. The compounds which contain only carbon and hydrogen are called hydrocarbons. Among these, saturated hydrocarbons are alkanes, where there is a single bond in them. Single bond A is there, the single bond is there, that means saturated will be there. Unsaturated hydrocarbon which contains one or more double bonds are called alkenes, and those containing one or more triple bond is called alkynes. So it not necessarily contain only double bond. Unsaturated double bond structure might have like alkene might have, if any bond is double bond, this is called alkene. Not every bond needs to be a double bond. If most of the bonds are single, and if any one or two bonds are double, in that case there will be alkene. And similar thing happens with the alkyne also. It is not necessary that the each molecule should form a triple bond. It is not possible for them. So at least one molecule should be there containing one or more triple bond. At least one should be there so it can be called alkyne. In hydrocarbon, one or more hydrogen can be replaced by these elements, and such that the valency of the carbon atom can be satisfied. What are these elements? These elements are oxygen, halogens, nitrogen and sulfur. So carbon seems to be a very friendly element, and so far we have been looking at the compound containing carbon and hydrogen only. These are called hydrocarbon. But carbon also forms bonds with other elements such as halogens. Halogens is a 17 group series of a periodic table: oxygen, nitrogen and sulfur. And when the hydrocarbon chain, in a hydrocarbon chain, one or more hydrogen atom can be replaced by these elements. What are these elements? These elements, such that the valency of the carbon atom remains satisfied. In such compound, element replacing hydrogen is referred as the heteroatom. So these heteroatoms and the group containing these confer specific properties to the compound. So these confer specific properties to the compound regardless of the length and the nature of the carbon chain, and hence they are called functional group. If these are like attached with in a hydrocarbon chain by removing one hydrogen or two hydrogen, they confer a specific property, they bring a specific property to to this compound regardless of their length and the nature of the carbon chain, and that is why these are called functional group. They gives the molecule a function, a proper functioning, a proper thing, a proper change, a proper properties. This is why called these are functional group. These are like when heteroatoms chlorine bromine is there, they form halo alkane, and oxygen forms multiple types of things like alcohol, aldehyde, ketone, and carboxylic acid. These are the formula. OH and aldehyde has this one, double bond with oxygen, single bond with hydrogen, and ketone has double bond with oxygen, and these are the carbon here, and carboxylate has OH and O bond. So these are the heterocarbon. Why? Because they replaces the hydrogen atom from the carbon chain. The element which replaces hydrogen atom from the carbon chain are called heteroatoms. Now study about the homologous series. Hydrogen atom and other atoms on these carbon chains can be replaced by any functional group that we have discussed above. The presence of functional groups such as alcohol decides the property of carbon compound regardless of the length of the chain. So, so these functional groups are decides the properties of the compounds. These functional groups, and for example, the chemical property of methanol, ethanol, propanol, butanol are similar. General formula for alkanine can be written as this, where n equal to 2, 3, 4. These are the formula for alkanes. It is CnS2n plus 2, alkene is CnS2n, and alkyne is CnS2n minus 2. So like understanding this formula, let I make you understand this. Why Cn S2n, like understand Cn. So here like C number, n is a number of atoms. Like if C has a n number of atoms, then H will have a twice of that, hydrogen have a twice of that. So C, suppose there are 2 molecule, then hydrogen must be twice of that. So hydrogen must be twice of that, because each two have a twice of this, 4 hydrogen formed, and this is what represents the CnS2n. Now what happens in the alkyne? There are CnS2n plus 2, so 2 atoms are extra. What are those 2 atoms? The corner atoms are extra. 2 corners atoms are extra, because the middle one will be the, suppose this is a middle one, and so these are the corner atoms. Their valency is still incomplete, so they will need one more hydrogen atom. So this is why in case of single bond alkenes, there is a plus 2 in the last along with the CnS2n, and in case of CnS2n only, it will be only the number of hydrogen atom will be just twice as the number of carbon atom. Here it is just twice, but here it is not, like carbon is not completing its valency, so there must be a double bond somewhere between. Here carbon needs a double bond, so it is completing. So here this carbon needs double bonds, and by doing this carbon forms the 5 bond, which is not possible. So in this case we have to remove one hydrogen atom. Okay, now it also got 4 bond, it also got 4 bond, it also got 4 bond, but it has only 3 bonds. So what we have to do, we have to form 4 bond in this case, but one extra hydrogen atom should be removed. So all these carbon atoms are has a 4 bonds, like not a 4 bond in the sense that 4 covalent bonds it is forming, and also they are each carbon atoms satisfy their valency. And what happens in the alkynes, as there are the 2 CnS2n. So let's discuss about the alkyne. Here the CnS2n will be there. That means carbon molecules are, if 1, then the hydrogen will be twice. So hydrogen are 6 here. So there is a -2 is here. That means hydrogen number should be here only 4. So how to make the hydrogen number 4? Here the carbon is not forming the bond here. It is not completing the valency. So we will add here one carbon, one more bond. So we have to remove this one. So one hydrogen atom has been removed. We need to remove one more hydrogen atom. So what will happen if we try to do by doing this and removing this? What will happen in this case? This carbon, the middle carbon atom got 5 bonds, so we cannot do this. So instead what we can do a triple bond here, and we remove one more hydrogen. This is how the triple bond is formed, and it is by Ne. Also the each carbon atom has 4 covalent bonds, and one atom should be. So even what happened in this case, like by doing this, this carbon got 5 valency now, the 5 bond, which is not possible. So we have to make it like each carbon should only satisfy their valency, maybe forming only 4 bonds, and also not more than 4. So we have to think how it can be placed. So in this case we have to also remove this hydrogen, and we can add one hydrogen here to make the valence complete. Now it has a 4 bond, 1 2 3 4 complete. It also has a 4 bond, 1 2 3 4 complete. It has a 4 bond, 1 2 3 4 4, and hydrogen, each hydrogen has a 1, and number of carbon is 3, and number of hydrogen is 1 2 3 4, which is twice -2. This is Cn, this is S2n -2. This is how the formula works, and this is how this bond forms. So let's discuss about the nomenclature, how we can name these compounds. Identity of the carbon atom should be here. We should be know like whether it is a single bond, double bond, or triple bond. Functional group is present. It is indicated in the compound name, where with either prefix or suffix is given. So these are the compounds, and suffix are these, and examples are these. So this is called chloropropane. It has a 3 carbon molecule, so it is a propane. It is a chlorine, to chloropropane. Why it is ANE? Because it is a single, it has only single bond, no double bond or triple bond. It is a bromopropane, same thing is here. Then alcohol is there. This is called propanol. Prop for a 3, nol fills alcohol, and this again aldehyde for Al. propanol, and ketone for one, which is called propanone, and acetic acid for oic acid, pentanoic acid, propanoic acid. So there is meth 8, prop, meth is probute, meth is probute, meth is probute, paint, hex, hept, oct, non. So these are the prefix are there. This is for 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10. If one carbon atom is there, this is called prefix start from meth. 2 carbon atom is there, this is called meth 8. 8 had ETH. And 3 carbon atoms are there, it will start from prop. 4, it will start with the bute. So this is how it goes. Propane is a 3. In propene there is a it is a hydrocarbon. It only contains hydrogen and carbon. And E means see, there is a trick. If there is a, this will be a single bond, and when there is a E, there will be double bond in it, and in case of Y, there will be triple bond. So E is here to double bond and Y is here to triple bond. Chemical properties of what are the chemical properties of these compounds? Combustion means burning. Carbon in its all allotropic forms burns with oxygen and give a carbon dioxide along with the release of a heat and light. When the carbon form burns with the oxygen, it forms carbon dioxide, and simply carbon plus oxygen will be carbon oxygen. And saturated hydrocarbon will generally give a clean flame, while the unsaturated hydrocarbon will give a yellow flame with a lot of black fume. And however, limiting the supply of the air result in the incomplete combustion even in a saturated hydrocarbon, which gives us a sooty flame. So if there is an excess of oxygen, so it will give a clean flame. If the oxygen is limited, it will burn like a unsaturated hydrocarbon, giving a sooty flame. Not even that much worse, because with it gives a lot of black smoke, but it does not. Fuels such as coal, petroleum have some amount of nitrogen and sulfur in them, and their combustion result in the formations of the oxides and oxide of sulfur and nitrogen, sulfur dioxide, sulfur monoxide, and sulfur trioxide, and NO3, NO2. So this forms oxides of the sulfur and nitrogen, which is a major pollutant in the air because it causes greenhouse effect. It is like major contributor. Why do substance burns with or without flame? We will observe the coal and charcoal in an agate heat sometimes just glow red and gives the heat without a flame. It gives heat without a flame. This is because the flame is only produced when the gaseous substance burns. So flame, wherever there will flame only burns when there is a gaseous substance burns. If there is no gaseous substance burning, there will be no flame. When the wood or charcoal is ignited and volatile substance present vaporize and burns with the flame in the beginning. So those who will vaporize, and only those forms gas, and only that will form only that will show flames. Luminous flames is seen when the atoms or gaseous substance are heated and start glow. How the coal and petroleum forms? Coal and petroleum have been formed from biomass. Biomass contain dead animals and dead trees, which has been subjected to the biological and geological process. Coal is a remains of tree, ferns, and other plants of the that lived millions of years ago, and these were crushed into the earth, perhaps by the earthquake or volcanic eruption. They were pressed down by the layers of earth and rock. They slowly decay into coal, and so coal is formed by the remains of trees, mostly trees. Oil and gas. Oil gas remains of the millions of tiny plants and animals that lived in the sea. So oil, gas and oils formed by the tiny plants and animals also. And when they died, their bodies sank to the seabed and were covered by the silt. Bacteria. These are the bacteria who attacks these dead remains and turning them into oil and gas under the high pressure, so they are being subjected to. Meanwhile, the silt was slowly compressed into rocks and the oil and gas seeped into the porous part of the rock and got trapped like a water in a sponge. So, can you guess why the coal and petrol are called fossil fuels? Fossil means dead, fossil means dead biomass, dead biomass. Biomass include both plant and trees. The coal is made from this coal is made from trees, ferns, and while the oil and natural gas is from remains of tiny plants and animals. Animals are also there. When they go like some chemical change, because bacteria eat them, bacteria attack them, and they form coal and petroleum. They convert into coal and petroleum. What is oxidation? In previous chapter, we have already learned about oxidation. Oxidation is the gaining of oxygen. Simple. If someone gain oxygen, it is simple. Although we will in high classes will come up will encounter with another definition where we include electron in it. Carbon compound can easily oxidized on combustion. In addition to this complete oxidation, we have reactions in which the alcohol are converted into carboxylic acid. Some substances are capable of adding oxygen to other, and these are known as oxidizing agents. Those like molecules which can capable of adding oxygen to others, these are called oxidizing agent. It helps they helps in oxidizing. What is called addition reaction? Unsaturated hydrocarbon add hydrogen in presence of catalysts such as palladium or a nickel to give a saturated hydrocarbon. And simply in unsaturated hydrocarbon there is a less hydrocarbon. In double bond there is two hydrogen are less compared to the single bond, and in uh, and triple bond it has a two hydrogen less compared to the double bond. And vegetable oil generally have a long unsaturated carbon chain, while the animal fat have a saturated hydrocarbon chains. See, plant fat has a unsaturated plant. What are the plant oils? These are the oils like sunflowers are these, plant oils are, we will study here I think. Animal fats are generally contain saturated fatty acid, which is said to be harmful for health. So animal fat is harmful, and while the oils containing unsaturated fatty acid should be chosen for cooking. So only the plant fat should be chosen. Like what are the plant fat? Like plant in the oil which forms from the plant, which is good for health, like sunflower oil, and like palm, which is not good, however, like is still a vegetable oil. And there are few more examples which I can't remember. Mustard oil, sunflower oil, and these are the oils which are extracted from the uh, vegetable. So what is the quality of these are unsaturated. Also one more thing, at a room temperature they are a liquid. So the major difference how you can identify whether it is a plant fat or animal fat. In animal fat, like cow ghee, they are solid at a room temperature. Animal fat are solid at room temperature, and they are saturated, which is not good for health. And however, vegetable fat are liquid at a room temperature, and they are unsaturated. They have a unsaturated carbon chain, and they are good for health. Substitution reaction. So there is addition reaction. What they are adding? They are adding hydrogen. Here the hydrogen is adding. So like alkyne which lacks the which was lacking hydrogen, they are introducing hydrogen in it. So from it converting from double bond to single bond. So opposite things will happen in the substitution reaction. What will happen? The hydrogen will be removed. So what will happen ultimately? The so it gonna be substitute. The hydrogen can substitute some other atoms. So let's study this. Unsaturated hydrocarbons are fairly unreactive. They are highly unreactive and are inert in presence of most of the reagent. However, in presence of a sunlight, chlorine is added to the hydrocarbon very fast in a very fast reaction. So if chlorine is adding, so it is replacing the hydrogen atom. So only then valency can be satisfied. So here the chlorine is substituting the hydrogen. The chlorine can replace the hydrogen atom by one. This is called substitution reaction because one type of a atom or a group of atom takes place of another type of atom. So it is substituting the position. So a number of products are usually formed with a higher homologous alkenes. Here there is a 4 hydrogen atom, and one hydrogen atom is replaced by the chlorine. Here it is substituted by the chlorine. So it is called substitution reaction. Some other compounds are ethanol and ethanoic acid of the carbon. Like properties of the ethanol. Ethanol has a ROH. R means carbon chain. OH is a functional group. Like this is the ethanol alcohol. What are the properties? Ethanol is a liquid at room temperature. Ethanol is commonly known as alcohol. In addition, because of it is a good solvent, it is also used as a medicine, such as in iodine, tincture, iodine, cough syrups, and many tonics, because as a solvent. So alcohol is soluble in water in all proportion. Consumption of the small quantity of the dilute ethanol causes drunkenness. So drunkenness, which alcohol causes, is ethanol only. And however, intake of the small quantity of a pure ethanol, which is called absolute alcohol, is called lethal. It can kill. And however, here it is ethanol is written, and methanol is a poisonous, and methanol is a poisonous. Alcohol react with the sodium, leading to the evolution of a hydrogen gas. When the alcohol is reacting with the sodium, the hydrogen gas is evolving, and etho oxide is formed. How do the alcohol affect the living beings? When the large quantity of the alcohol is consumed, it tends to slow the metabolic process and depress the central nervous system. It slow the metabolism and also the depress the central nerve system. This result in the lack of coordination, mental confusion, and drowsiness, and lowering the normal inhibition, and finally stupor. Stupor is a state of being nearly unconsciousness. Like ethanol, intake of methanol is very in a very small quantity can cause death. Methanol is oxidized to methanol in the liver, and the methanol react rapidly with the components of cell. It coagulates the protoplasm in much the same way as the egg is coagulated by cooking. The methanol also affected the optic nerve, causing blindness. So this is a very harmful thing for consumption. Methanol is very harmful, and ethanol is important in an industrial solvent. And to prevent the misuse of the ethanol produced for industrial use, it is made unfit for drinking by adding the poisonous substance like a methanol in it. And this is called denatured alcohol. Dye are also added to the color, the alcohol, to color the alcohol, so that it can be identified easily. This is called denatured alcohol. Alcohol as a fuel. Sugarcane juice can be used to prepare the molasses, which is fermented to give alcohol, ethanol. Uh, some country now use the alcohol as an additive in petroleum, since it is a cleaner fuel. So India is also using 20% blending of alcohol in fuels. Properties of ethanoic acid, CS3COH. Ethanoic acid, commonly called acetic acid, acetic acid, like, and carboxylic acid. It belongs to the group of carboxylic acid. And 5 to 8% of the solution of the acetic acid is called vinegar, and it is a preservative in pickles. And vinegar is also used in chow mein. Often freezes during the This often freezes during the winter in cold climate. This gives rise to the name is uh, glacier acetic acid. And carboxylic acid are the weak acids. Weak acid means their pH is not maybe from like weak, like maybe 4 to 4 5 6 7, 4 5 6 around it. And reaction of ethanoic acid. Esterification. Ester is a most commonly formed reaction of an acid and alcohol. When the ethanoic acid reacts with the alcohol, ethanol, it forms the ester. And ester is a sweet smelling substance, and making it used in making perfumes and flavoring agent. On treating a sodium hydroxide NaOH in it, which is a alkali, the ester is converted back to the alcohol and sodium salt of the carboxylic acid. Alcohol and sodium salt of carboxylic acid. This reaction is also known as saponification, used to prepare the soaps. And soaps are the soluble. Soaps are sodium and potassium salt of long chain carboxylic acid. Let's discuss about the soap. This is what happens. Soap, in most dirt is oily in nature, and As you know, the oil does not dissolve in water. The molecule of the soap are the sodium phosphate, sodium or potassium salt of long carboxylic acid. Sodium, this is important. Sodium or potassium salt of long carboxylic acid. These are the soaps. These are the molecules of soaps, and the ionic end of the soap interact with the water while the carbon chain react with the oil. And the soap molecule thus formed. The structure is called micelle. We will study what is these are the micelle. While the ionic end molecule, which faces outside, ionic end part faces outside, this forms the emulsion in the water. So what is happening? Soap are a molecule in which the two ends have a different properties. One is hydrophilic, which loves hydrogen, and another end is hydrophobic, which hates hydrogen. So what happens is it interacts with the hydrocarbon. This is suppose oil, and this is a soap molecule, and this is a carbon chain, and this is a group, sodium and potassium chain salt of carboxylic acid, upper one. So it is a hydrophilic. So it uh, so so it loves water, and hydrophobic, this attaches with the this oil. So it attaches this way. So this structure is called micelle. This is formed as micelle. Soap is formed. Soap is a form of micelle. Is soap in the form of micelle is able to clean, since oily dirt will be collected in the center of the micelle. Oily dirt will be collected in the center micelle, and the soap's micelle are large enough to scatter light, hence the soap solution appears cloudy. You are about to end this chapter. While bathing, you ever observed while bathing that form is formed with difficulty, and an insoluble substance remains after washing with water. So insoluble substance will remain after washing with water. Reaction of soap with the calcium and magnesium salt, which causes hardness of the water. This is caused by the reaction of soap with the calcium and magnesium. So calcium and magnesium, what they are doing, they are causing the water hard. They are making the water hard. This problem can be overcome by using another compound called as detergents, and as a cleaning agents. And detergents are generally sodium salt of sulfonic acid and ammonium salts of chlorides or bromides ion. Both have a long hydrocarbon chain and do not form a insoluble participate with calcium and magnesium ions of in hard water. So the hard water do not work in it, do not form any insoluble uh, participate, and remains effective in hard water. So soap is only works in a soft water, and in which there is no calcium and magnesium. And detergent in this case also working in a hard water, and in which there are calcium and magnesium salts. Let's quickly revise this chapter. Carbon is a versatile element, forms the basis of all living organisms. This large variety of compound is formed by the car. This large variety of compound is formed by the carbon because of its travalency and catenation. Covalent bond sharing the electrons. In covalent bond, there is a sharing of electron between two atoms, and from a straight chain branch, carbon forms three types of molecules. One is in straight, one is in branch, one is in rings. The ability of the carbon to form a chain give rise to the homologous series of the compound. And functional groups such as alcohol, aldehyde, ketone, and carboxylic acid bestow character properties to the carbon compound that contains them, and this is called functional group also. Ethanol and ethanoic acid are the carbon compound for important daily life. Ethanol is alcohol which is used in the industry. Also, people drink to get drowsiness. Ethanoic acid is also used in a vinegar. And action of soap and detergent are the based on the presence of hydrophilic and hydrophobic group in a molecule. It helps in emulsifying the oily dirt, and it removal hence its removal. Here ends this chapter, and thank you for watching this.